Hello friends, welcome to Tech by Gaurav K. Hope you are all doing fine. Today we are going to discuss about a new buzzword in the industry, which is MLOps. And if you have watched the previous videos on DevOps and DevSecOps, this would fall in line with that, as MLOps derives its fundamentals from the DevOps and DevSecOps strategy. And why we are talking about MLOps? The reason is now we are using machine learning and artificial intelligence in many software projects. Many applications are using it across the industry, and managing those projects is not that easy, right? And that's where MLOps comes into the picture, and it using the fundamentals from DevOps, it actually enables the machine learning projects to reach their culmination, like reach the production stage in a fast, in an efficient manner, and be successful. So let's try to understand what exactly is MLOps, why it's required, and what are the benefits. And at the end, we'll try to find the minute differences between MLOps and DevOps. So, in general, when a machine learning project is started, there are a couple of teams that actually become part of it, right? So initially, we have data in the beginning, and that actually is used by the data engineering team. So the DE team uses that. It works on the data side, data front, on the data preparation, like it ingests the data, data is prepared. If big data is coming, you need to make it digestible by the further teams. So that's what is done by the data engineering team. So they are primarily involved in the data kind of normalization and data uh, like preparation stage. And then we move on to the data scientist and ML engineering team. They're kind of on a similar note, they are working, but they bring different aspects to the machine learning project. So the scientist team is basically focused more, traditionally they have focused more on the algorithm part, the ML algorithm, and they look at the project from the statistics perspective. So that's what they bring. They bring their mathematics expertise from statistics, and they are aware about the algorithms, and they try to understand the project requirement, and they try to implement and make sure that they help the project by building the right model. And the ML engineers are basically software engineers. So they basically bring the engineering background to it, the core application development engineering background. And that's where they bring their input. They're also familiar with the ML algorithms to an extent, to the statistics part as well. And in some companies, you have a distinction between these two roles. In some companies, the distinction is not there, and you would say that an ML engineer is kind of a mix of a data scientist and ML engineer, right? And it works both ways. So in this way, these two teams, the data scientist team and the ML engineering team, they actually help develop the model for the project. So they actually help in developing the ML model for the project. And then after the development of the model, the main work comes for operationalizing it, right? For making it a production ready model. That's where the ops teams comes, who actually help in productionalizing the entire machine learning model. So that's kind of the gist of the entire machine learning project life cycle. So that's how it actually is run. There can be more teams or less teams depending on the project requirement as well as the organization that is implementing it. But this is kind of a gist of a normal ML project that teams use, right? So let's try to see how MLOps actually helps these teams uh, make the deliver the model in a more efficient manner, in a more secure manner, and in a more agile manner in the sense that the accuracy of the model or the requirement of the model is delivered on a fast basis, right? So let's try to deep dive into the actual workings of the MLOps strategy. So here you get a ballpark view of the stages that are involved in the MLOps uh, cycle. So we start with the EDA portion here. So that's basically diving deep into the data, right? You try to explore the data, and you try to find it, if there are any uh, issues with the data, like the data is in the right format or not. So that's where you decide to either correct the data, or you ask for more data, or you ask for uh, correct format of the data. So that's where you explore the data initially, and you understand if the data provided to you is suitable for the ML project or not. So that's where the EDA comes. You apply certain statistics here, and you perform visualizations that actually helps you, right? Visualizations are performed. So that actually helps you in understanding if the data is uh, not of a certain field, right? Like there are not many outliers, right? If you understand the terminology outliers, like there are not many outliers, and the data is actually following it's actually normalized kind of data, right? So that's where we actually understand the data, and after that, we make sure that whatever work has been done in terms of the statistics operations, in terms of the visualizations, right? These are actually can be shared across the team, right, to the next phases of the life cycle of MLOps. So that's where we need to make sure that this is an editable version of the EDA work that we have done. It can be shared across different teams, and it should be in the form of uh, very basic format so that it can be understood, and the workings of it can be analyzed further. So that's the first stage that comes into the picture, and data is being looked into here. Now, next stage comes where we actually go into the data preparation stage. This is where, let me bring one more aspect to it. In the EDA, the basic work is being done. It can be done by the business analyst. This is also kind of a role that I have not discussed earlier, but they're kind of can say lie between data engineers and data scientists. So business analysts do perform such activities for EDA, and in some organizations it can be the data engineering team itself as well. But yeah, that business analyst, or rather data analyst, I would say, is a term that you should be familiar with as well. Okay, so next stage is the data preparation stage. This is where data engineering team comes into picture, and they apply their knowledge using different tools to make the data in a way available to the model preparation stage, which comes next, right? So that's where the data engineering team basically makes sure that the data is actually available in the right format. This is where data engineers actually come into the picture, and this is where you use different kind of tools, right? Means in if you're talking about Azure, where I am working quite closely, you use different tools like ADF, Azure Data Factory, and there's Azure Data Bricks as well that we use. So that's where all these tools actually help you make the data available via automated pipelines to the next stage, which is the developer stage. So this is where the core data engineering work, or the ML engineers work, come into picture. So they actually use the ML algorithms. For example, if we are talking about like the most popular libraries that are being used, like scikit-learn. So that's the one that we use. And similarly, you can use other algorithms as well, other libraries as well, like TensorFlow. There are so many other libraries, and depending on the project requirement, you would choose the right library, and you will use that to develop your models, and you would actually perform a lot of experimentation in this stage, right? This is where the experimentation comes into the picture. And that's the key thing which defines a data science or a machine learning project, right? So this is something which we normally don't see in any normal software development lifecycle. We see that in a machine learning project or a data science project. because this is an experimental science, right? You don't know in the very beginning what you're going to actually start end up using, right? So you have the data, you have a business requirement, and now you try to bring those together and give the right model that could solve the business problem, right? So this is where all the experimentation happens and the ML algorithm is being developed, is being used to develop a model. So this is where we end up having a model. So that's the key thing to note here. In this stage, we get our model, and then we come to the stage of training and retraining. So this is something which is the core part of the experimentation, right? You don't know from the very beginning that the model that you've created is the final model or not. You need to train it, and you need to understand if you're what you're getting is the right version of the model or not. If not, then you need to go back to the develop stage, and then you need to refine your model, and then come back to the train stage, and then train the model again and get the evaluation done. And further, this is a kind of a cyclical process. And once you reach a stage where your model is acceptable after the training stage, then you move it further and you perform the actual review, where you kind of test it against a kind of a test data set, and perform the review and you evaluate it. And if you see that the model is good, and it's giving proper predictions as per your requirement, then you actually move on to the next stage, which is the deployment stage, where you actually the model from development to production. So this is where the production deployment comes into the picture. So this is where you would actually deploy your model into production. And next, we would go and start inferring the data from a live data set, right? So you would start the model will be in actual use, right? Like an application is being used by users, your model will be in actual use for performing live prediction or live analysis on real-time data, right? And that's where you understand if your model is actually working properly or not. So model drift is it needs to be analyzed here, because what happens is sometimes, or in many of the cases, when you get the training data was uh, maybe used to build the model 6 months ago, and the live data which is coming now is pretty much evolved, right? Or it is evolving at a different pace. So now we need to monitor. That's where we need to monitor the model, how it is inferring the live data, and then based on that drift, if we analyze, then we need to go into the kind of a retraining of the model, kind of a rebuilding of the model, right? We create multiple versions of the model based on the drift that we analyze, and that's where we keep on evolving our model with time. And that's where monitoring is a very key aspect to the machine learning project, because you can't just be happy with the one version of the model, and because data will keep evolving over time, and there will be drift sooner or later, and you need to analyze your model, and you need to be ready with alerts and corrective measures that you need to take. Sometimes you can have automated measures as well. So that's what you need to keep in mind, and you need to use that information to refine your model, retrain your model, and bring it back to production to work on the live data in a better way. So that's kind of a gist of the MLOps strategy. If you had watched the old videos on DevOps and DevSecOps, this is kind of a you can actually correlate certain aspects to it, but not entirely. So this is kind of the eight stages that we go through in an MLOps uh, development cycle. So let's try to define a few aspects. Like let's try to go a little deep and try to define how actually this all boils down to, right? Although you might find it pretty much similar to what we have discussed before, but I'll just go over it once again. So we do the EDA. We use certain tools to do the EDA. We go into the data prep and feature engineering, and then we perform the model training and tuning, and then we review it, and we apply the governance on top of it, and then we infer the data, make it available in production, and then we deploy and monitor it, And then we perform automated model retraining. That's what I was discussing where when I was mentioning about a model drift. So we need to have automated kind of measures to take care of the model drift and allow model to be retrained and evolved over time. So this just give you another kind of review of the discussion that we had before. So let's now like try to understand uh, how actually MLOps helps the data scientists and data ML engineers, right? Uh, get the machine learning project delivered faster. So basically, what they do is data scientists and ML engineers, their core focus is on developing models, right? And since it's not a straight away science, it's quite an experimental science, right? So it's a very complex process to develop a model, right? You need to perform data ingestion. Once again, data ingestion, data preparation. Then you need to do model creation, training, tuning, and then you further need to deploy it, monitor it, and keep on reviewing it, and then make sure that it is actually providing the right kind of predictions, right? So that's what happens in the monitoring and reviewing section. And there are many more other things, right? So what is happening is the the data scientists and ML engineers, they are pretty much into this section, right? They are involved in this section, and they if they don't apply the MLOps strategy, making a model ready for production becomes a challenge, right? And that's where they need kind of a automated strategy to help them deliver the model in a into a production state in a faster and efficient way, right? So this is how actually the MLOps strategy helps them to deliver uh, the ML project in a faster and efficient way. And next is like uh, how actually it helps the overall business objective, right? So few things are there, right? We have talked about the efficiency part, right? We mentioned about the efficiency, and then it makes the we need to talk about the scalability as well, right? With cloud and MLOps, we actually can monitor thousands of models, right? And we can actually manage those models, like keep on training them, reviewing them, and monitoring them for any kind of drift. So that's also an important thing. With MLOps, you get the scalability for the entire ML project, right? And the next important thing is the risk management or risk reduction, right? So in this, what we do is we when we have this strategy, right, MLOps strategy in place, we can actually make sure that the model is as per the compliance requirements for the organization or for the industry that the model is being used for, right? So we can apply the uh, necessary rules and regulations to the model and make sure that it is as per the standards for the model and for the industry. So that's where risk management also becomes a key factor for this using this MLOps methodology. So if we try to conclude the whole discussion on what is MLOps, so basically hopefully you got the gist of it and it helped you understand how actually MLOps is helping ML projects reach to production in a faster and efficient way. So just go through this means go through this video and please help me with the comments if you have any, and I will further be sharing sessions on related topics like AI ops and related to cloud. So that is something which you will be getting in the next few uh, days and weeks. So I'm trying to make it a regular practice to bring these sessions to you. So if you like the video, please do like the video, and please do subscribe for getting uh, access to such content, because I'm trying to post these contents on a regular basis. So uh, would love to hear your views on this. Do comment on the video, and see you in another session. Thank you. Bye bye.